After 90 days of putting them head-to-head on production-grade microservices, here is the unfiltered verdict. Cursor is not a drop-in replacement for GitHub Copilot, and if you treat it like one, your productivity will actually plummet for the first 3 days. Copilot remains the undisputed king of low-latency, inline, tab key, autocomplete. It's a high-speed co-driver that stays out of your way. But if you are trying to refactor a legacy multi-file module or onboard onto a complex codebase, Copilot feels obsolete. Cursor's multi-file context, codebase indexing, and composer agent turn it into an autonomous project partner. However, that power comes with a steep tax. You have to stop writing code and start learning how to write precise, declarative system instructions to get the best results. Today, we're breaking down the hard engineering trade-offs of both tools, the exact cost-to-benefit ratio for a $200 plus developer's workflow, and why the optimal setup might actually be using both instead of choosing one. The fundamental mistake most staff-level engineers make is treating these tools as interchangeable commodities. We approach Cursor and Copilot as if they are simply autocomplete plugins, ignoring the architectural reality that they solve for entirely different stages of the software development lifecycle. By forcing Cursor to act like a high-speed inline completion engine, we introduce unnecessary friction. We end up fighting the IDE's context window management, leading to prompt fatigue, where you spend more time crafting instructions for an agent that isn't optimized for micro-completions than you would have spent writing the boilerplate yourself. Conversely, using Copilot to handle complex, multi-file refactoring or architectural migration is a recipe for technical debt. It lacks the deep, repository-wide awareness required for high-level synthesis, often hallucinating imports or missing cross-service dependencies that a more autonomous, context-aware agent like Cursor would catch. Smart engineers get this wrong because we are conditioned to optimize for speed at the keystroke level. We fail to recognize that the AI coding landscape has bifurcated. One tool is a low-latency tactical accelerator, and the other is a strategic partner for system-level reasoning. When you try to use a hammer to turn a screw, you don't just fail to secure the fastener, you strip the head. In our case, that stripped head is your codebase integrity. Maintaining a binary mindset, choosing one tool to rule them all, is the primary reason many high-earning developers report a net zero productivity gain after 3 months. You are not meant to choose one, you are meant to understand the operational delta between them. This brings us to the deep analysis of their distinct operational paradigms. GitHub Copilot truly shines as an elite tab accelerator and high-speed co-driver for daily coding sprints. Its strength lies in low friction, subliminal inline suggestions, perfect for boilerplate, syntax, and short function generation. Copilot excels at anticipating the immediate next logical step, keeping you in a flow state and reducing keystrokes for known patterns. It's built for velocity within a tightly scoped context, indispensable for micro-optimizations in your coding rhythm. Cursor AI, however, operates on an entirely different plane. It's an autonomous project-aware partner designed for complex, multi-file tasks. The key workflow difference is its explicit prompting model. Unlike Copilot's simple autocomplete, Cursor demands a learning curve for effective prompting. As one user noted, it took 3 days to get really productive. This investment is crucial. Cursor isn't about the next line, it's about describing a desired outcome or architectural change across potentially dozens of files. Think of it as a strategic agent for large-scale refactoring, identifying cloud cost optimization by suggesting efficient data access patterns, or dissecting complex legacy code for failure modes. It provides leverage for tasks Copilot simply cannot comprehend. Where do they break? Copilot's limitations become stark when attempting complex, multi-file refactoring or significant architectural migrations. Its contextual window is too narrow. Pushing it beyond inline completions invariably leads to generic, often incorrect, suggestions that contribute to technical debt. Conversely, Cursor breaks down when forced into Copilot's role. Using Cursor for simple boilerplate or micro-completions generates prompt fatigue. The overhead of crafting precise instructions for a trivial task far outweighs the benefit, making it feel worse than typing the code yourself. This is precisely where the interchangeable commodity mindset leads to inefficiency. For staff plus engineers, understanding these distinctions is both a productivity hack and a career accelerator. Mastering Cursor's prompting for complex, context-aware tasks represents a significant skill gap. It elevates your role from merely implementing solutions faster to strategically designing and executing them at a higher level of abstraction, directly impacting production engineering concerns like system resilience and cost efficiency. While Copilot optimizes the how, Cursor empowers the what and why, making both indispensable, but for very different parts of our demanding roles. To move beyond anecdotal evidence, we must look at the empirical data surrounding AI-assisted development. GitHub's own internal metrics, published following the integration of Copilot into their IDE ecosystem, reported that developers completed tasks 55% faster compared to those not using the tool. This velocity gain is primarily driven by the reduction in cognitive load during boilerplate generation, a phenomenon observed in the 2023 GitHub October's report where developers reported spending significantly less time on repetitive syntax. However, productivity in production engineering is not solely about keystrokes saved, it is about architectural accuracy. When we look at Cursor's implementation, which leverages a deeper context window via Claude 3.5 Sonnet, the paradigm shifts toward agentic workflows. In a recent analysis of multi-file refactoring tasks, developers utilizing Cursor-native features like Composer were able to execute complex dependency migrations, such as moving from legacy REST patterns to gRPC, in roughly 40% less time than those manually navigating via Copilot. This isn't just about speed, it's about the tool's ability to index the entire codebase via RAG, retrieval augmented generation. For instance, when Cloudflare experienced their 2023 outage, the Post-Mortem emphasized that the primary bottleneck was context fragmentation. Tools like Cursor attempt to mitigate this by maintaining a persistent, project-wide semantic index, whereas Copilot's architecture is optimized for localized, latency-sensitive completion. For a staff plus engineer, the choice depends on your objective. If your goal is low latency, acceleration for high-throughput feature work, Copilot's sub-100 ms latency remains the industry benchmark for developer experience. If your goal is architectural synthesis across a 500K line repo, the overhead of learning Cursor's prompt-heavy interface is a necessary investment for a measurable increase in complex problem-solving throughput. Verdict and takeaways. After 90 days of using both Cursor AI and GitHub Copilot on real projects, it's clear that each tool has its strengths and weaknesses. GitHub Copilot excels as a high-speed co-driver for daily coding tasks, providing low-friction inline suggestions and reducing keystrokes for known patterns. Cursor AI, on the other hand, operates as an autonomous project-aware partner for complex tasks, leveraging a deeper context window to provide more accurate architectural suggestions. The key takeaway is that these tools are not direct replacements for each other, but rather complement each other in different aspects of the development workflow.